Yeah, we're going to go through division and multiplication of fractions. So what's good or easy about division, multiplication of fraction is if we were adding and subtracting, we need a common denominator, which we pretty much don't have, minus these threes. But because it's division and multiplication, that's not the case. We can go through with different denominators and be okay. According to BEDMAS, the very first thing we want to do, and maybe we should write this on the side here, our BEDMAS. Our BEDMAS tells us to deal with all of the brackets. So if we look inside the brackets, we could deal with these, but they're going to end up being decimals, and I want to work with fractions because if I have a fractional answer at the end, that'll be very, very exact rather than rounding some decimals that we'll probably have to deal with, okay? So I look inside here, and there's nothing really to simplify. This says it's -3. Really, the entire fraction is negative, right? So whether I put the negative on the top or on the bottom here, it won't make a difference. I just can't do it to both. If I do it to both, that's going to change everything. And we're going to talk about it because it happens over here. Here's a -14 and a -6. There's some rules we have to know when we're multiplying and dividing. Essentially, the rules are for integers, but it works for this case too. If you're multiplying two positives, you're going to end up with a positive answer. If you're multiplying two negatives, you're still going to end up with a positive answer. And if you're multiplying a negative and a positive, you'll end up with a negative answer, okay? So whether it's multiplication or division, these rules still hold. So if I have a negative divided by a negative, really this is just one big positive. I can eliminate both of these, okay? They don't really need to be there anymore, okay? Now here, think of this like a negative and a positive, which gives us a whole negative, and that's why I say the entire fraction is negative. Those are the rules.
And if the negative symbol's outside the bracket?
You can just apply it either to the top or the bottom. It's going to make things simpler for you.
Okay, so it's still negative.
Yeah, just put it to one of the numbers, either numerator or denominator, because it'll make multiplying and dividing much easier because it gets a little confusing that way. Okay. Otherwise, nothing really in brackets, no exponents, and then here we go. So division and multiplication. We do them in an order of how we read usually. That's the easiest way to go about it. So we go from left to right. So the very first thing we have to do is divide two fractions. But what's funny is we really don't do any division. We really just turn division questions into multiplication, okay? So we invert and multiply the second fraction here. So when I go to write it, we have 20 over -3. This becomes now a multiplication question, and we're going to invert this fraction here, okay? So now it's going to become 9 over -35 or -9 over +35. It doesn't actually make a difference, okay? So I'll put it like that. And then I'm just going to bring down the rest of this stuff. Actually, I'm going to turn that to a positive. I'm just going to write it as 14 over 6 and then divide 4 over 3. So we've now moved around this fraction. When we multiply fractions, we do the top by the top and the bottom by the bottom, okay? So I'm going to do 20 by 9. That's going to be 180, okay? And I'm going to do -3 times -35. Well, that's actually really helpful because I know a negative times a negative is a positive, so my value on the bottom will now be positive, okay? And it's going to be 5, carry the 1, 105. So I've now just evaluated these two fractions. So I'm just doing one pair at a time, okay? So we bring down the rest of the question. Times math. 14 over 6 divide 4 over 3. Okay. Same rule. We're going to multiply the top by the top. Yeah, and multiply the bottom by the bottom. 180 times 14. So I'm going to use a calculator. Are you guys allowed to use calculators on these questions?
No.
No? Okay, then we won't.
No.
We'll do some side calculations. 108 times 14. Okay, so we do the 4 or the 1's columns times everything. So 0, that becomes 32. And then 4 plus 3 is 7. And then 180. So we add 0, 2, 5, and 2. Do you want me to go through that? Or are you okay with that?
That's fine.
You okay with that? Okay, so the number on top is relatively large. We have 2,520. And on the bottom, I have 105 times 6. 6 times 5 is going to be 30. 6 times 0 is 0. That's where we carry the 3. And then 6, so 630. So the number on the bottom is 630. So that's the evaluation of these two fractions now. And we still have the very last part. So we bring down the last division of 4, thank you, over 3. Now, like we said before, we don't really divide fractions. We're just going to turn it into a multiplication question. So we keep the fraction on the left the same, 2520 over 630. And we invert the other fraction. This will now become 3 over 4. Same rules as before. Multiply top by the top, bottom by the bottom. This is a pretty big number. It's a good thing we have a lot on the side here. 2,520 times 3 will give us 0, 6, 5, carry the 1, 7. So the number on top is 7,560. Okay. And the one on the bottom is 630 times 4. So 0, this is 12, carry the 1, 24, 25. Over 2,520. Now, I should probably reduce this. They probably want in lowest terms.
Yeah.
Looking at it, I have a 0 on each side. So essentially, I can divide both the top and the bottom by 10. That works out really nice. So the zeros both disappear. So now I'm left with, I'll put a little equal sign here so we know we're still working. 756 over 252. We could do some of our divisibility rules. I definitely know 2 is going to go into it. I wonder if 4 will. Let's take a look. 11, 18, 2. I don't know if it will. So let's go by 2 here. If I divide both the top and the bottom by 2, and this is the tedious part. Technically, the answer above, the one we have now, and everything we continue down are the exact same numbers. This is just reducing it in lowest terms here. So when we divide this by 2, that's going to become, I'm going to do this division in my head here to help us out. That goes in 3 times, 7 times, 8 times, 1, 2, 6. I can do 2 again. Repeat this whole process, divide everything by 2. Are you okay with how I did that?
Yeah.
Yeah, okay. You can always just keep doing division on the side. The whole idea is really we want to get used to our fraction stuff here. This becomes 1, 8, 9. This becomes 6, 3. 3 goes into that. 3 goes into that. Oh, geez, we can get quite a few here. So now we're going to divide everything by 3. It would have been nice if I got the correct number to divide by off the bat. Thank you. But we'll just keep going through it as part of how we do this. 6, 3, and that becomes 2, 1. 3 goes into both of those. 2, 1 over 7. 7 goes into this. Oh my gosh, the answer is actually 3. Yeah. So if we go back up to the top,
Sorry, I'm confused. How did you get 3?
21 divided by 7.
Oh, okay.
So if I divide 21 by 7, that's 3, and 7 by 7 is 1, so it's 3 over 1.
Yeah.
So really what I could have done, I should have realized this, but this is divisible by this. Now I know you said we didn't use a calculator, and I wasn't sure if we were going to end up with a fractional answer, so I decided to keep reducing the fraction. I'm trying to bring up a calculator here. Let's just double check our answer. 7,560 divided by 2,520 equals, yeah, the answer is 3. So it goes in 3 times.
Is there an easier
way to reduce that fraction? There is. Up here, what we could have started doing is when we were, this won't go down, there you go. When we were doing our multiplication here, we could have started reducing our values, okay? So, let's pause this. I'm going to do it on the side here. Copy this out. This is where one of our steps would. Really, if you, like I said before, if we wanted to simplify this, we could have started doing cross reduction, I guess is the best way to do it. 3 and 9, I can divide both of those by 3. So if I divide this by 3 and this by 3, it now is a 1 on the bottom, and this is a 3 on top, okay? And I look for a value that goes into both 20 and 35, and I can divide both of those by 5. And that already starts to help with our reduction, okay? 20 divided by 5 would be 4. We have 4 here. And negative 35 divided by 5 is negative 7. So now when I multiply the fractions, these are much easier numbers to also work with. So we can kind of use this as something to help us reduce the entire way. Okay, so we're going to continue through this the same method. So now 4 times 3 is 12 over negative 7. A much easier number to work with. So we look again. The next two values we work with are 14 and 6. Okay, and we look for cross reduction again. And lo and behold, you can look for reduction within your own bracket. For instance, 14 and 6, I know I can divide by 2. But it'll actually work a little better if I divide both of these by 7. It brings the numbers down far lower, so they're easier to work with. So I divide that by 7 and that by 7. And when I do that, the numbers I'm going to work with are negative 1 and positive 2. Okay? And 12 and 6, I can divide both of those by 6. Right? So again, work with really small numbers. 12 reduces to 2. 6 reduces to 1. And look at this. This is much easier to multiply than what we had before. I forgot to bring this down. Still have to divide by 4 over 3. Okay? We still have to divide by 4 over 3. So when I do that, well, 2 by 2 is 4. 1 by -1 is -1. And we have division, 4 over 3. Okay. So now the last step here is divide. Remember we said we turn into a multiplication question. So I have 4 over -1 times this inverts. Okay. So it becomes 3 over 4. And let's look for cross reduction again. I can't do anything with the -1 and the 3. Is that negative correct? Did I do that? Oh, this should have been a negative here, which would have made this positive. The reason I noticed this now is because I know our answer wasn't negative in the end. Okay, so I just fixed that. 3 and 1 don't reduce, but 4 and 4 both reduce by 4. So I divide that by 4 and that by 4. And now we're left with 4 divided by 4 is 1. So 1 over 1 times 3 over 1.
It's 3.
Is 3 over 1, which is essentially just the value of 3. So really, if we take a look here, it's going to be hard to see, but I divided by the values of 3 and 5 here. I divided by 7 and 6 here. I divided by 4 down here. 1, 2, 3, 4, 5 steps of division. On our other page, I divided by 10 here, then 2, so 1, then 2 again, then 3, then 3 again, then 3 again. So I had 1, 2, 3, 4, 5, 6 steps. And what did I say? 6 steps on 1, 2, 3, 4, 5 steps here. Roughly the same number of steps, just the numbers on the second page are much easier to work with if we can think about it when we're going through. Okay? Same thing, just a different method on how to get there.
Method work for like anything?
Yeah, as long as it'll reduce into a whole number. You might eventually get to an improper fraction or a fraction that doesn't reduce anymore, like maybe 3 over 4. That might be your final answer. And you can leave it as a fraction of final answer. Okay?